Hi guys, Shouvik here. Welcome back to our channel. So today we will solve another question from Leetcode itself. So let's get started. Yes. So today we have the largest divisible subset. So first we will understand the question, then we will jump on the intuitions building and post that the solutions iterations we will do. Yeah. So on the question, given a set of distinct positive integers, so all the elements present in the nums array is positive and all of them are distinct. Now we have to return the largest subset of answer such that every pair of answer I and answer j of the element in the subset satisfies the below conditions which they have provided. Now I think you guys know what is subset. Subset basically point actually that is non-contiguous. So subarray should be contiguous and subset should be non-contiguous. Like it can be contiguous, but it can be non-contiguous also. There is no strict regulations of a subset. Subset can be non-contiguous and there is no order. Now so like most trickier things is subset. Now if they ask to find a subset, then you have the rigidity. You have to find the elements in the contiguous portions and they should be follow the order they have occurred in the nums array because they are contiguous. That should be like inherently followed. And another thing is subsequence. In subsequence you can skip in between some elements, but you should follow the order of the elements. But here they have asked for subset. So on subset there you can violate of contiguous, that is it should not be subset. It should not be a subarray, and it can also violate the subsequence principle, which is should be in the order. So it can violate the subsequence principle also. It can be like you can choose 3 first and then you can put 1 second. First you can put 3 and then you put 1. So that is also a valid subset. Now the condition is like every elements you choose, out of them it should follow. If you choose any two pair in the subset, then one should be divisible by another. Like the bigger one should be divisible by the smaller one. So that condition should be followed. Now if there are multiple solutions, you are like you have the liberty to you can return any of them. So I think this question is very straightforward, and if I am going to iterate you to some test cases also, then you will get the gist. So on test cases, if you can see 1, 2, 3, so we are returning output 1 and 2 because every two pair, if I choose 1 and 2, the bigger one, that is 2, is divisible by 1. For 1, 3 also, 1, 3 is also accepted because here you can see for 1, 3, if you choose any two pair 1 and 3, 3 is divisible by 1. This bigger one is divisible by smaller one. But if you choose 1, 2, 3 all, right, so you can say the principle should not be followed, because if I choose 2 and 3, then 3 is not divisible, completely not divisible by 2. So that's the reasons 1, 2, 3 cannot be come to a one single bucket, because the reason, or more specifically 2 and 3 should not be in the same bucket. So yeah guys, so that's all about the question. And on this particular case you can see that we have the liberty, like every pair should be divisible. Every pair, if you can choose any two pair, all are divisible. And our constant is in the range of 1000 and our nums can grow as big as 2 into 10 raised to the power 9. Yeah, so that's all about the question parts. Now I think on the solution part, there are few cases. So just by initially seeing the question, what is the first intuitions is coming to your brain? So the first intuitions that should come to our brain is, do we have choice? Yes, right. We have choice, because for a particular element, it can be part of my answer or it can't be part of our answer. It can be part of our answer, or else it can't be part of our answer. So there are choices. Now if we have choices, then there should be some way we can think about in terms of recursion. There should be some way in terms of recursion. So I have written the recursion solutions, but there is one small catch on the recursions. That's the reasons I have to go to the iterative versions of the DP. So yeah, I think the constant also is giving you the sufficient in, like it is of under 1000. So you should be able to create a in square type of DP matrix for sure. So the altogether constant is a very strong, giving a very strong hint of pushing you to on the part of the DP. So So that's the things. But on recursion, you can write the recursion solutions. But on the recursion solution, there is a problem, guys. So if they are going to ask us the length of the such subset, then we should be good. Then we should be good. But if of any particular question, if they ask to generate the subarray or generate the subsequence or generate the subset, if they ask for the generate the DP solutions that you are providing without length, if they ask for the elements which actually forms that length, subarray, subsequence, subset, anything. So in that case, you have to write that. You have to write the iterative versions. You have to write the iterative version. So that's the reasons I am not putting the recursive solutions of mine in this particular video, and I am not like submitted also on the recursive version, because on recursive version you might be able to calculate, for my case also I am able to calculate it with the size of the array in dig of n square, but on space it is going to be kind of that is the backtracking I have to do, and for backtracking the complexity we know it is of n factorial, and n factorial is directly going to us at the end. So that's the reasons I am not putting the recursive versions, but I am going to directly on the iterative versions of these particular DP solutions. So now what actually the factors we should have to look for, what actually the factors. So if I am standing, if let's suppose I am standing to a particular elements, so let's first arbitrarily take. Now let's go to our favorite OneNote. Where is it? Untitled page. Yes. So now go to our favorite OneNote. So OneNote, what actually, like, I know. So how you have to write your DP? How actually you have to write your DP? So when you start writing your DP because you know, right, from recursions, the DP actually the updated versions of the recursion. So DP is nothing. When you write a iterative DP, it is just an update of your recursive versions with some parameters reverse. So let's not go that deep. What parameters we have to revert? What parameters we have to reverse, or what is? I am giving you a very general situations. I am giving you a very general situations. Shit. Yes. Am I able to write, guys? No, writing is not happening. Can I write now? Yes, now I am able to write. Yeah, so what actually the things? So let's suppose I have number A, B, C, D, E, F. Right? If let's suppose I have this number, I have this num set. So when you are going to write an iterative DP, so just stand yourself, just try to stand yourself to any arbitrary portions. We will come then the base cases later, but please try to form the functions call. Please try to form the functions call dependent parameters. When you are able to build an arbitrary functions call dependent parameter, and when you are going to jump on the next calls, what's the parameters is going to be changed. If you are able to answer that particular question's answer to you, then writing the iterative versions is actually the cakewalk. So let's suppose I am standing at this particular index, and I am following a DP table. Before understanding the entire solutions, don't ask yourself how we are going to pre-computed that value. Let's not ask. You will get DP is internally doing its job. DP will internally do its job. You will get the intuitions when you are for an arbitrary point. If you are able to build your answer, then you will definitely get the gist how the previous pre-computations we are using, how DP is basically building that. You will able to get. But for now, when you are at the very initial state, let's not focus on that. Let's not focus on this. Otherwise, you will not get the gist. So let's suppose I have another DP table also. And I want to calculate for this particular DP of, if I consider it I, so I want to calculate DP of this particular index I. So what actually our DP should store? DP should generally store our answer. So DP of I should point to what? DP of I should basically brings what value to you. So DP of I is nothing but considering nums I as the last elements of the subset. So before I am writing these things, last elements. So we have to do a sorting of the nums. We have to do the sorting of the nums, because I guess it is very intuitive why we have to do the sorting, because when you are building the subset, so what actually, if you are thinking on the terms of greedy also, if if you are appending a particular elements, if you are appending to a particular elements to a already pre-built subset, what actually the things you are looking for? It should be divisible by all of others. It should be divisible by all of others. So just I'm writing here only. So let's suppose I have A, B and C in my subset answer. So here everyone is divisible by everyone. A is divisible by B is divisible by C, but they are not in order. Like order means so they are not sorted. Now if I want to append D altogether, if D is divisible, if I can add D to it, then I have to check. Is it divisible? I have to check. Is it divisible by B? I have to check. Is it divisible by C? I have to check everyone. When I am going to append D to ABC. But if I am giving you particular things, if A, B, C is sorted, if A, B, C is now sorted, something like this, C is the biggest one. Now, do you think I have to check for D and C? Rather than if I can directly check for D and C, if I am able to check, if D modulo C equals to 0, then can I check? Can I say D modulo A is also divisible? D modulo A is also equals to 0, and D modulo B is also equals to 0, because the reason is C modulo B is equals to 0 and B modulo A is equals to 0. So all of them are following this. All of them are following the principles already. So I don't have to check everyone. So on this particular case, when they are not sorted, I have to check all of them. But here I will only check with C, only check with the largest. So I think it is very common mathematics, and you guys are going to get the gist. So that's the reasons. That's basically the driven factor. We have sorted our num. So because when we are trying to append the particular elements to the already pre-built subset, then we don't have to check everyone. We'll just take the last one. Very last one. So now when you are standing, so now we will write considering nums as the last elements. Why last elements? I already provided you the intuitions, because if we are make it divisible by my last element, so all of its previous are like blindly divisible. They should be bound to divisible, because by transitive property. If B modulo A is equals to 0 and C modulo B is equals to 0, then C modulo A is also equals to 0. That is very basics of mathematics of transitive dependency. We can prove that. So that's the reason I am making it sorted first. So I will just take the very last. I will just take the biggest one of our running subset, if I can append to it. Right. So now considering the num psi as the last elements of the subset can, what I have written. So if dp of I is storing, considering num psi as the last elements of the subset, what is the largest size we able to build at index I. This is going to be went out. This information is going to be went out by your dp of I. Your dp of I will give you this information, right? So dp of I, every dp of I is storing, considering this particular nums I with including nums of I, what is the largest subset? What is the length of the largest subset? Whose last is nums of I, is stored by dp of I. So I am repeatedly stating, because that is actually the fundamentals to going further to our calculations part. So we are iterating on these directions. Right? So now we have to calculate what's the value we have to put to this particular index. And we have our nums. So that is our nums of I. So can you guys tell me what actually my dp of I should be? So if my ith pointer, or more specifically I have to say the last pointer, when my last pointer is standing at this particular index which I am pointing, if my last elements is pointing, last index is here, so what is the largest subset we can build considering these particular elements as the last elements? Can you guys tell me? Yes, we can. How? So first of all though, we will check to all of its left to all of its left, because we know that is the largest we are trying to push. We are trying to push to whom any of the left to any of the left to any of the left, right? That is the largest. Nums of I, nums of last, we are trying to push to whom any of the left, any of the left. So what is the basic conditions to we are able to push? We know our things are sorted. We know our things are sorted. So that is the conditions we are following. We initially make our nums as sorted. So what should be our allowances to push to update my DP of I, to update my DP of I? Can I say if this particular index is j, if this particular index is j, so my nums of I, so that is the lastest, that is the most last, that is the most biggest. So this nums of j should be able to, or more specifically nums of last, where our last pointer is storing, should be divisible by nums of j, should be divisible by nums of j. These conditions, at least it has to follow. At least it's these conditions it has to follow. So only then we can push what is the subset is stored, what is the subset is stored at this particular value. We should be append this d to it, we should be append this d to it, right? So now if these conditions meet, so we will check to all of its left, and for every left. So if I can write the pseudocode, we will loop our last variables from 0 to n. That's what we are doing for sure. And for every last, we will running, let's suppose a j loop from 0 to last minus 1, last minus 1, we will iterate. And what is the conditions? What should be the conditions to nums of j as a valid candidate? I know all are sorted. So do we have to check everyone? No. I will just check if that particular nums of j, so my first condition should be if my nums of last is divisible by whom? By my nums of j. If it is divisible, then can I directly, so now I know I have to store something to my DP of DP of last, obviously. I have to store something to my DP of last. But what? So what actually I have to store? If you have this DP table and if you have this, so that is your nums. You use your nums for just checking the conditions that it is divisible by the very last elements. Now, can you use something from your DP? So you are trying to calculate for this particular index, which I am highlighting. This is your last, and you are able to make a validations to this particular index, that this particular index nums value is divisible by the nums of last value for which we are trying to calculate our answer. So can you state me what is the answer then? What is the answer then for DP of I? So DP of last. What is the answer then for DP of last? Can you guys tell me? It's nothing but the what is the value? What is, because this DP, I know for every DP what it is storing. Every DP is storing. Considering my nums of I as the last elements of the subset, what is the largest site? We have, including that index that our DP of I is storing. So for if this particular index is divisible, so what is the DP of I value it is holding? What is the DP of I value is holding? So that value is basically stating on this particular index elements as the last elements, what is the largest value? It is able to build. What is the largest value it is able to build, including this particular index as the last. And we are appending one more elements. We are appending one more elements to it. So what is the conditions? You should be able to update your DP of last. So it should be the divisible, and because every DP, that is the maximum subset we have to generate. So DP of particular index is basically stored. So what actually DP of last then stored? DP of last will store considering this particular DP of last as the elements. What is the largest size? We are interested for this largest size. So out of them, so there can be multiple elements. There can be multiple j's. Multiple j's is divisible. Multiple j's are divisible. So we are not interested to all of them. So what is the maximum among them? So our another condition should be my DP of I, my DP of j, where the divisibility has done. So that particular DP of j plus 1, if I am append one more value to it, it is going to be more than my DP of last value. What is the current value I have found till now? That is more than my DP of last. So on that case, I will definitely update my DP of last to 1 plus dp of I, 1 plus dp of I. Very simple, very simple. And what is the size then? And we are also storing what is the max size. What is the max size we have find till now? What is the max size we have find till now? So initially I am going to start everyone to be with 0. Everyone I am going to start with 0 max size. And initially we will make our dp elements to everyone as 1 to n, everyone to be 1 to n, because it is very intuitive. Like every elements considering as the itself is a valid subset. So that's the reason I am making everyone to be 1. And like this way we are updating. And what is our max size, how it should be updated? Its update is very simple. So we found some deserving candidate to update our max. So why not we are taking the max of my max size, whatever the max size we currently have at, to the dp of last, So this actually how your dp table should be formed. And now your max size variables is also storing what is the largest subset, what is the length of the largest subset. It is stored by max size. Now can you guys now bring the nums array or the answer array ready? Can you guys make the answer array ready from it? I guess we definitely do. We should definitely do. But yeah, before that, I will just quickly tell it to you guys to the code once, because I have written the exact same things to generate our dp tables. So here you can see that I have taken in to len of nums. I have sorted it. I have initialized my dp to 1 to n, and I have put max size to be 1 initially. You can put 0, 1, anything's fine. Now I am iterating from last variables till n, that is from 0 to n, and for i variables to 0 to last. Last means last minus 1, because the last whichever the index we are putting here, it's exclusive. It is just taking the just left of it, right? So that is the thing. So it is going to be iterated from 0 to last minus 1. The exact things I guess I have written over the one note, that is iterating from 0 to last minus 1. Now what we are doing, we are first taking if my nums of last is divisible by nums of I. If that is so, then my if dp of I plus 1 is more capable, is more powerful than my dp of last, then why not we are updating our dp of last to dp of I plus 1, and we will also maximize our answer to max size plus dp of last. Like this way we have the max size of the subset that is going to be formed. If they are asking for the max size, then from here only, like just after the next line we can return it, but they are interested to the actual subset altogether. So that's actually the reasons also, guys, like so that's actually the reason also, guys, like I feel this is not a like medium level question, that's for sure, because till this points what we just done, like on the one note, like reaching this till this points is very, quite difficult, and then generating the answer, like if you are able to solve this kind of questions previously, then after your dp build, then generating the answer you should be able to do. But like if you are not, then generating the answer, I have to say, is another medium level question, that's for sure. So that is more than medium, that is definitely nice. So now how you can generate your answer? Now you have the dp ready. Now you have your dp ready. So what actually your dp stored, considering the index where considering that particular index, what is the largest subset size we have it? What is the largest subset size we have it, right? So that is actually stored by dp. So can I use this information to generate my answer? If you solve this particular question, then it should be very easy for you. But if you are not, then I will give you the gist how we can generate if your dp is ready. So that's the reasons, like recursion is going to be the same things, like generating, like giving you the maximum max size variables. If they are interested for max size variables, that you can easily do by recursions, but generating the answer array is not going to be helped by recursion, because to generate the answer you will end it up of doing backtracking, and if you are doing backtracking, their complexity is going to be of n factorial kind of things, which is directly giving to you TLE. So you have to, like, there is no excuse, you have to run the iterative versions, if they are interested for only the length, then we should be fine with the recursive version. So yeah, so now when you have this dp ready, so let's suppose I have this dp ready, so that is my dp, and everyone has some value. Let's suppose it has p, q, r, s, t, and I have this max size. I have this max size. Let's suppose as s. It should be any of the variables in the dp array. It should be any of the variables at the dp array. So how you can generate your answer? You and one more factors you should know. You have a nums array. You have a nums array of same size 1, 2, 3, 4, and it is, if I write it a, b, c, d, e, it is following these conditions. It is sorted, and every elements are unique, so it should not be less than equals to, it should be directly less than, not less than equals to. So if you have this initial configuration ready to you, can you give me the answer? Yes, man, I can give you. So what is the first things? What is the actual directions you should be start to iterate? What is the first directions you should iterate? So I should definitely pick this particular elements because that is matching to my max size. So I will run a loop from left to right, I guess you are guys getting why we are running from left to right, because our nums is sorted, and divisibility we will only use when we are iterating reverse, because we have the just biggest number already seen. But yeah, if you are not able to understand, I will do a standard dry run, then we will definitely. So we will do a running from very last. So first my I pointer will stand at here. If it is equals, if my dp of I is equals to my max size, no, so that is not going to be take my answer. My I pointer is moved to here. Now I will keep another pointer. What is the previous we have seen? What is the previous we have just taken to the last of my answer? What is the just next we have just seen before considering this? So initially it should be -1, because we are starting from very fresh. We did not encounter any of them. We didn't add anything to our answer. We also should have some answer which should be initially empty. So what we are doing? We are running a for loop from reverse. We are running from n-1 to 0. And inside them, what is the conditions to push something to my answer? If my dp of I at which index, now we first go to generate your dp, second go to generate your answer. How you will generate your answer? Using your dp. So now we will use our dp table as max we can do. So what actually the valid conditions? So lying at the index I, standing at the index I, when I can take it, take this particular value. If my dp of I is equivalent to my max size, because you see, right, you already saw for t we are not taking, because t is not altogether to my answer. So t altogether not coming as a last elements to the largest subset it has at. It's very straightforward, guys. I guess you are getting. So I will. So now we have an opportunity. If this conditions meet, then we have an opportunity. Now if my previous, now we will check if my previous is altogether -1, that is it's very start, then do we have to consider any other case? No, we don't have. So we will directly push this particular value. What is the value? It's nothing but the nums of I. So like here, don't guys push dp of I. Dp of I is basically giving you, considering this particular elements as the last elements, what is the size? What is the element actually? Nums of I. Please take a note on this particular option. Push to your answer to nums of I. And what is the previous then? For the next calculation, what is the previous? Previous is going to be updated to your nums of I. Right? And now we have taken one elements to our answer, so our max size. And what is the size we are then looking for? So one size lesser, minus equals to 1. So that is the, when we are just the very first elements we have encountered, like for the s, when we just encountered this s, we have something to be pushed. What is the value to be previous? So d is our previous, and let's suppose, and our max size is going to be, initially it is s, then it is going to be q. Let's suppose it is going to be q. So when it is going to be r, it is not match. And now when it is going to be q, now again these conditions meet. My dp of I is equals to my max size. My dp of I is q, and my max size is also q, because it decreased by 1. It's q. Now we have to check. The divisibility conditions. So that's the reasons I am taking a previous variable. Now what is the biggest one as it is sorted? So that's the reasons, guys, I told you to go from right to left. So what is the, as the very biggest is the right. So what is the biggest one? It's previous. It's the previous variable. If the previous is going to be divisible by the nums of I, to the nums of I we are calculating. If it is divisible by, if it is divisible, then yes, that is also a candidate for you. Yes, you can take your s1s. What is the value? Again, push nums of I, and I think it's exactly same. Your prev is also going to be update. Your previous is also going to be update to what value? Your previous is also going to be update to your nums of I, and your max size is also going to be decreased to minus equals to 1. That is very intuitive, right? So, and if it is not a match, so let's suppose on this particular case only, if this is also q, and let's suppose this is also q. So let's suppose this part, when we are checking on this particular index, so my nums of, let's suppose this index as a k, my each, what is the last we have taken, each modulo my nums of k, not equals to 0, not equals to 0, right? There can be a case. So on that case, if this case is met, if this case is met, na, so we are not taking this. We are not taking it. Should be divisible. It should be divisible. Then we are maybe jumping to this queue, and we are trying to take it. We are trying to, and let's suppose for this it's met. Then we will take it. We will push to my answer. We push to my answer, and like this way, finally you have your answer ready. You can happy to return your answer. So now you guys maybe ask that your answer is on reverse. You can pass your answer to a reverse function to make it in the order they have asked for. But yeah, as I already told, subset is not an order things. If they have asked for the longest subsequence, then you can do a reverse. Then please do a reverse, guys. Please do a reverse. If they have asked for what they have asked for, if they have asked for subsequence, if they have asked for subsequence, please do a reverse. Please do a reverse. But as they have asked for subset, you should be good to return the answer as it is. So exactly these things I have written on the code. But yeah, for understanding, I will iterate to you guys definitely. So I have initialized my answer to be empty, previous to be -1, and I am iterating from right to left. I guess you got the intuitions why we are iterating to right to left, because on that case our previous is going to be in hand, and we will do a divisible, but we will check the divisibility without previous. So that's the reason we are iterating from right to left, and also like intuitively also like getting max. What is the most probability of getting our max? It is on the right side only. That's the reason. So if my dp of I is our max size, so that is the very first condition. If this condition is met, and if our previous is -1, then we are doing the exact same things. Answer dot append nums of I, previous equals to nums of I, max size equals to not, max size minus equals to 1. And if my previous divisible by nums of I, if my previous is divisible by nums of I, okay, then also we got a candidate. We will do the again same things. Answer dot append equals to nums of I, previous equals to nums of I, max size equals to max size minus equals to 1. I can write the same thing. Also you guys can write it on a single line also. If any of the conditions is going to be satisfied, then also it should be good. It is kind of a little bit more cleaner way of writing the things. Yes, it is giving correct. Let's make a submit. I think it should be fine. There is nothing. We just doing the things in the two things. We are putting it to a single line. Yeah. So that's all about this particular question, guys. I have to say it is not a medium level questions. Like if they have asked for length at least, then also we can use a DP kind of things. Then also I can say it is a medium level questions. But as they have asked for like printing the things, if you know the way of how we are generally printing, it is a very standard template based question. I have to say, if you know after generating your DP, if you know how to print it, then you should be like this particular portions is like a memorizations. You just have to write the things. Nothing means you don't have to use your brain power. But yeah, if you don't know, then finding the first like ready creating your DP tables and post that like generating your answer, it is more than the medium level question, I have to say. But yeah, like that I have to say it is the most optimized time and space complexity for this particular solutions. Now let's quickly do the TC and TC analysis, but I am pretty sure you guys is already able to pinpoint what is the time complexity for this. What we are doing, we are writing a big of n squared here for sure, and we are doing another big of n here for sure. So the time complexity by and also we are doing nums of sort. Please take care of every operations you have did and write your time complexity on this order. Like your first you are doing a n log n, just sorting it, right? Then you are doing a big O of n squared, right? Because you are creating your DP table. Then what you are doing, you are generating your answer. That is going to be take another big of n. So that is exactly the time complexity for this particular. All the lines we have considered. All the lines we have written in the code we have considered. And what is the space complexity, guys? The space complexity is nothing but a big O of n squared. So for sure for the DP, sorry, not n squared, big O of n for sure of the DP we are following. And else apart from that, max size is a variable, single variables. No, we are not using any of this. So that is it. On space part, it is taking a big of n space. So that's all about this particular question, guys, and this all about this particular question solutions. That I have to say it is the most optimal time and space complexity for this particular solutions. But please guys, I will definitely suggest you to write your code on your own, and please try to submit to your own. Otherwise, it is only by seeing the video is not going to help you on the long run. So please try to solve your own and submit to your own. Then only like you will feel the gist. Every line's importance you will feel on your own. So please feel the every line's importance to your code. So how you can get this? Just writing your code on your own. Please do this, guys. I'm repeatedly stating. Only seeing the video is not going to help you. Not going to help anyone to longer run. So, and I hope you guys are able to understand the entire solutions, entire problems, entire solutions, entire time and space complexity, each line's analysis. And if you are able to do so, then what are you waiting for? Please do subscribe to our channel and please turn on the notifications so that when we are going to live with our next video. So that's it guys, that's it for today. Bye guys, bye bye.